So in this video, I'm going to develop a new library. It's called Snail. I invite you to follow along. It is the SVG library for rendering graphics and quick experiments. I have already prototyped the functionality. I'm still yet to add the function definitions, so let me just show you the setup I have. I'm using CMake for project configuration, and these are all the functions we are going to implement. So there are functions for creating, destroying. Oh, I removed these two. So create destroy canvas, SVG canvas, then we can render different shapes, line, circle, ellipse, rectangle, etc. And we can undo the operation, translate the canvas, fill and save it. I have already added the boilerplate, so we have a few definitions here, color codes, then the SVG shape appearance, which is the stroke width, opacity, color, the fill opacity, color. Then there is also some fonts that are web safe and available in most web browsers. We have the font weight, style, and the text decoration. Then there is the structure, data structure, that takes in all of the information that will be applied to each shape. Oh, to the text element of the SVG. And to simplify the process, I have a point, which is a data structure containing X and Y coordinates. And the canvas itself, it has the width, the height, and then they translate Y and X, so we would be able to translate the canvas the way we want. And then there is the string surface. So this is the data structure we are going to use. And then there is function declarations down below. All right, let's actually move on to the implementation. Let me make it bigger now. So we have the canvas create, and we're going to return the SNL canvas instance. Saving the width and the height. The translation will be set to 0 automatically, and then the surface, we need to create a string, a new string. So I'm going to create Vita star create len, I believe, and that should take in the, well, VT stands for Vita. It is the library, my custom library that I have created. You can find it on GitHub. Well, I will put the link into the description. So here's the Vita library. And it is a simple standard library that is meant to help the development in C. And it contains containers. It has containers, string manipulation, path file handling, datetime utility, etc. You can read more on GitHub. So it is create len, and then the array default init elements. And I'm going to use the null instead of the allocator, so it should use the calloc-free functions of the C standard library. And that is it for this function. Then we need to destroy the surface. That's the only thing. So that will be stir destroy canvas surface. That's it. Now then pre-allocate. If we're going to do some extensive graphics rendering, string allocations may slow it down, so we can pre-allocate some amount of bytes to speed up the rendering process. So that will be stir reserve, and that is canvas surface and bytes. Now let's get to the rendering part. So now we need to render the SVG line. So we're going to have the const char format string, and that shall be the line, then the first x coordinate, like this, and that is going to be point contains an int. Alright, so that is D. Then y1, then x2, and y2, like this, and it should be D here, so we're going to format the integers. Then we need to add the style, and the style takes in the stroke, and that is the stroke width, I believe. Then no, it's not the stroke width, it is the stroke color. Then that will be a string. Oh no, it will be RGB, RGBA, %T, oh, and for you int 8 type. And I don't want to use this, it's ugly. So let me check how does the U work. It still works as expected. Okay, let's use the U. Let's use %u. %u, then %u and %u. So that is RGBA. Then we have the stroke width. And the stroke opacity. Stroke width is an integer. I don't think it should be bigger. Stroke width of 254 is probably enough. So let's make it U. Then we have stroke opacity. That is a float value. Then we have filter. Well, we're going to add filter later. That is probably it for the formatting. Then what we should do is probably register append f. Oh, and I'm going to add the new line at the end, and we have forgotten the closing bracket. Like this. Yeah. Now it takes in the canvas surface, the formatting, and the arguments. So start.x, start.y, and.x, and.y. Then appearance dot stroke color dot r. Yep. And the line does not have the fill attribute, so we cannot fill the line. So it's like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, we're done with the line. So let's go ahead and save the canvas, implement the save functionality so we can test it right away. So it only saves the canvas, so that's gonna be, oh, do I need to include, oh, I need to include more. So we need to include the writing utilities. So that's going to be util, no. Then it's probably system file IO, yes. And then down here, we will have the additional functionality for file IO. file, write line. So file, write line, it takes in the file name and the buffer, which is our string surface, like this. And that should be it. So let's try to build it. Get rid of this, build it again. It built successfully. Alright, now we can test it. So let's go to cd test, tests, and we have our main.c file. Let's open it up. So tests, main.c. And for now I have a simple test here for checking whether it successfully compiles with both of the libraries, so the Vita and the Snail. Alright, so let's do make and make run to test it. Alright, it works. Now let's create a canvas. The auto-completion doesn't work properly this time. Canvas, canvas, alright. We will do without it then. SNL canvas create. $24 and $640. Then let's do SNL canvas pre-allocate 1000 and SNL canvas destroy canvas. And it needs the canvas. It needs the canvas. And we can render here. So SNL canvas render line. Create, pre-allocate, render line. It needs the canvas instance, then it needs the SNL point. Let's make it 0, 0, SNL point 50, 50, and the SNL appearance default like this. And that should be enough. Oh, so we have a typo here, so canvas like this. We have a typo down here. Canvas. Alright, so we need to rebuild. And make run. Yes, we do not save the SVG output yet, so before we destroy the canvas, let's save the output. So canvas save and it needs the canvas, and that's going to be test.svg. Make run. Yep, now we have the SVG test. Oh, so it probably won't display anything at this point. Let's test it out. So so it won't display anything now because we need to add a few headers. So let me close this off. Let me put this here and so when we create the canvas, we need to add a few things. So now canvas, create a canvas like this, and return the canvas. And down here we need to prepare a few things. So we need to initialize the canvas. So stir and F, and that's gonna be a very long string. So canvas.surface, and then that's going to be SVG, and inside of here SVG new line, and right here we need to add the width percent. What is width? It is uint. It works. Alright, so it's still %u then. %u, which is the width, then the height. Then we need to add the view box. And then we need to add the XMLNS. So we need to change the double quotes to a single quote. That is probably the source. So and that is it for the canvas initialization. And then at the very end, when we save the canvas, before we save it, we need to finalize the canvas surface. So we need to finalize the canvas and then we save it. And that's going to be restore pendef svg, like this. This is the last thing we need to add, I think. So canvas surface Now let's try to build it and make run. And now let's try to open it. Line 1, column 2. Line 1. What happened here? So we have let's actually print the surface. So let's print the canvas surface. Then here and oh. Like this. So that works. Then why does it write the last thing? Oh, so it overrides the canvas every time. Then why does it do so? So we append here, then we append here. So on the second line, we should have gotten this line as well. And then this part. Create and append. All right, then is it because I'm copying the struct? All right. Then let's then modify the definition of the function, declaration of the function to return a pointer. So it will return a pointer. It will return a pointer then. Then we need to allocate canvas. So we need to allocate the canvas. Size of snail canvas. like this. So we'll allocate enough memory, and then we update the canvas. Then we initialize the canvas, and then we return the canvas. And then when we destroy the canvas, we destroy the surface. And then we need to destroy the canvas itself, like this. Alright, let's move back. So it returns a canvas, we destroy the canvas. Okay. Now we create a canvas, we destroy it, we save it. Let's compile this. Like this. Read only? What do you mean? Oh. So basically because of... Where is it? So because of this, it's read-only. And alright, so now it builds. Good, now let's go to tests and test it make and make run. Huh. And that doesn't work. Why doesn't it work? I'm appending, right? I'm not writing to it. So canvas line, I do append. So I append additional line information. So when I print this, it overrides the string. Why does it override the string? Alright, then let's check the Vita library then. I think the problem lies in there, so let's go to source, container, stir, and check the append functionality. So validate, shrink, surface size. Oh. Okay, so that just sets, it resets the surface, so it overrides the surface every time. So this is a mistake I've made here. So, and that VFMT just, okay, let's go down here. So it's somewhere here, and yep. Yes, so it basically overrides the data every time. It overrides the data every time instead of appending data to it, so I will need to fix this. So let's go here and open an issue. This is something I didn't notice when I was writing it, so it is stir append f overrides the string every time due to vt stir vt stir. Oh, vfmt. So it overrides the string every time. Must append. Overrides it. Overrides it. Submit. Alright, that's it, I guess. I will have to fix this and then I will create a new video and return to you.